Hi, welcome to this lesson on trigonometry, trigonometric functions part 1. Let's have a look at question 3. We're given the function f of x equals negative 2 times tan of 3 over 2 times x. Okay, so it's a tan graph, so we're expecting things like asymptotes. Right, write down the period of f. So this is in the general form right now. A times tan of bx plus p plus q. Okay, there's no p value, so there's no horizontal shift. There's no q value, so there's no vertical shift up or down. But there is an a value of negative 2 and a b value of 3 over 2. So this a negative 2 means it's a vertical stretch by a factor of 2. And because of the negative, it's also a tan graph that's been reflected about the x-axis, the standard tan x graph. Okay, and the b value tells you the new period. So the new period of f is going to be the old period, which is 180 degrees for tan, divided by that b value, 3 over 2. So when you divide by a fraction, you multiply by the reciprocal, so times 2 over 3. Okay, 180 divided by 3, that's 60, times 2 is 120 degrees. So every 120 degrees, the tan graph will repeat its wave. The point AT2 lies on the graph. Determine the general solution of t. Okay, so when you substitute x equals t, your y value is 2. So that means f at t equals 2. But if I put t for the replacement of x here, I get negative 2 times tan of 3 over 2t equals 2. Then if I divide both sides by negative 2, I get tan of 3 over 2t equals negative 1. Now this is a trigonometric equation in its general form. One trig ratio with an angle equals a number. Okay, so where is tan negative in the quadrants? That's the second and fourth quadrants. But with tan, we only need one solution, which will be this solution that I look here in the second quadrant. If you use the fourth quadrant solution, you would still expect to get the same values coming out. Okay, so let's go ahead and solve here. So I need a reference angle. My reference angle is going to be tan inverse of positive 1, which is 45 degrees over here. So therefore, in the second quadrant, the solutions will look like as follows. The angle, 3 over 2t, that's really important, that's the entire angle, is equal to 180 degrees minus the reference. So 180 minus 45 is 135 degrees. Plus k times the period of tan is 180. Okay, now if I multiply both sides by 2 and then divide by 3, so I'll get t equals, so 135 times 2 and then divided by 3. So 135 times 2, that's 270, divided by 3 is 90. And then 180 degrees divided by 3 over 2, we already did that because of the period, that's 120 degrees. Okay, where k is an integer. All right, so these are the values or the general solution for that t value that can lie on the graph. T equals 90 degrees plus k times 120. So you'll naturally ask yourself, but wait a minute, 90 degrees, 10, that's an asymptote, what's going on here? So when you plug in, for example, if k equals 0 here, you get 90 degrees. If you plug in 90 degrees here, 90 times 3 is 270 divided by 2 is 135. So you end up taking tan of 135 times negative 2. Not necessarily tan of 90. Tan of 90 we know is an asymptote. Okay, so don't let that throw you off. Okay, so that's the general solution for t. Now we want to draw the graph of f in this given interval and clearly label all asymptotes, intercepts with the axes and endpoints of the graph. So immediately, first things first, I go for asymptotes when it comes to tan. I know that in general for tan x, right, the asymptotes are 90 degrees plus k times 180 degrees. All right, now remember your asymptotes are x values, right? And because of this 3 over 2, that adjusts everything by a factor of 3 over 2. So to find your new asymptote values, you would take the asymptotes of the original tan x graph, so the asymptotes of tan 3 over 2x, right, asymptotes, would be equal to that 90 degrees divided by 3 over 2. Okay, plus k times the 180 degrees divided by 3 over 2. So everything gets affected by that factor. So let's think about what that turns into. 90, that's going to be 90 times 2 over 3 plus, and then we know that already factorizes, simplifies down to 120 degrees. So what do we have here? 90 goes into 30 times 2, so 60 degrees plus k times 120. So when k is 0, I have my first asymptote here, x equals 60 degrees. If I put k equals 1, that goes to 180 degrees. Okay, so there's another asymptote, label it. K equals 2 will take us outside of this domain. Okay, so what about negative values? K equals negative 1. 60 minus 120 is negative 60. That is within our domain. And then if I subtract another, so that's going to be outside this domain here. Okay, so there are the asymptotes. Right, so now we just need the intercepts with the axes and the endpoints. Okay, so the endpoints are essentially going to be on the right-hand side. Yeah, it's an asymptote, so there won't be an endpoint. It'll approach the asymptote. And on the left-hand side, whatever the negative 120 degrees value gives us. So I'm going to go to my table again. Negative 2 tan 3 over 2 alpha x. Okay, no second function. We're starting at negative 120, ending at 180. And I'm always use 30 degrees generally as my safety net. So there we go. Negative 120 degrees gives us 0. That's an endpoint and it's an x-intercept. Negative 90 degrees gives us negative 1. So negative 1's over here. All right. And then see, negative 60 degrees gives you error. So that means it's an asymptote. So it's approaching the asymptote that way. Okay, next. At negative 30 degrees, it's positive 1, which is up here. At 0 degrees, it's 0. So that's an intercept, an x and a y intercept. 60 degrees is an error, and again, that's to be expected because of the asymptote. So it'll look something like this. So it's going to approach the asymptote that way. It's going to go through there, and it's going to come down and approach the asymptotes. The tan always approaches the asymptotes. All right, and then from 120 degrees, that gives us 0. So that's another intercept. 150 degrees gives us negative 1. Okay, and 180 degrees gives us error because that's what we expected, right? It's going to be an asymptote. So it's approaching the asymptote there, cuts through the x-axis, goes through that point. Okay, I didn't have to label that 150 degrees point, but I did anyway, so it's fine. So this is the graph of f. Okay, we've got all the intercepts, okay, x and y intercepts. We've got all the asymptotes labeled, and we've got the endpoints labeled. Awesome. Okay, so now we want to use the graph to determine for which values of x will f of x be greater than or equals to 2 in that interval. Okay, so let's check where is, this is f of x. So f of x greater than or equals to 2 just means where's the graph equal to 2 and where does it lie above 2. So if you look here at this dashed line, that's y equals 2. You can see at this point here and at this point here, they are equal. And then to the left of this, the graph is above 2. Okay, and then to the left of here, the graph is above 2. That's the only time. Okay, so we need to figure out when is the graph actually equals to 2, right? But I think did we solve something like that yet? Yes, we did. Okay, nicely. So that's why they gave us that. Okay, so it's at 90 degrees plus k times 120. So when k is 0, it's 90 degrees. Okay, so I haven't drawn it very accurately. It's over there. All right, so that's supposed to be 90 degrees. All right, 2. And then the other one, see, it's between negative 30 and negative 60. So if I put k equals negative 1, it's going to be 90 minus 120. That's negative 30. Okay, let's just double check that. Let's bring up the table again. Negative 30 gave us negative 1. Let's just double check. Ah, look at that. I didn't put negative 2. Easy way to catch your mistakes, right? So if I push equals there again, same start, same end, same steps. Okay, so now we need to just adjust this graph a bit. Okay, so let's go ahead here. Okay, I think the endpoints and all that should still, in theory, remain the same. and intercepts and stuff. It's just some of the values now will have changed. Okay, so let's come back here. At negative 120 degrees, it was still 0. At negative 90 degrees now, it's negative 2. Okay, so that's important. Let me just get the pen up here again. Negative 60 degrees, still get the asymptote, so it's going like this now. Okay, it'll still have the same shape. Negative 30 degrees now, it's negative 2. And then 0 is going to be 0. Yeah, sorry, so negative 30 degrees, positive 2. Okay, so let's put that point up here. So that's negative 30 degrees, 0. And then 30 degrees should be negative 2. Okay, great. All right, so there's the function here. Okay, and then after that, 90 degrees is 2 and 120 degrees is 0. So there's 90 degrees, so it goes through like that. All right, and approaches the asymptotes. Okay, so now we have a more accurate representation here because we've actually drawn the function correctly this time. So 90 degrees 2, negative 30 degrees 2. So we've seen that to be greater than or equals to 2, this is true if and only if x is an element from. So from the asymptote negative 60 degrees up until negative 30 degrees. And we can include that value because of the or equals to. So first of all, the asymptote, we can't attain that value. So negative 60 degrees all the way up to 30 degrees, but we can include that. Union, where does it start up again? So again, from this asymptote of x equals 60 degrees, can't attain that. And it goes up to 90 degrees inclusive. So that is the interval for when the graph f of x will be greater than or equals to 2. Okay, it'll lie above that blue line. And lastly, describe the transformation of the graph f to the graph of g. So g of x is given as negative 2 tan of 3 over 2x plus 60 degrees. Now, immediately your first thought might be, well, I see a plus 60 degrees there, so obviously it must be a horizontal shift of 60 degrees to the left because of the plus 60. That's where you got to be so careful, okay, because it's actually not. So this form here of f of x is given as a times tan of bx plus p plus q. Okay, now we suddenly have a plus p value here. Okay, but now that phase shift, when you've got a period value here of 3 over 2, right, is need to be taken into account for. Okay, so what do I mean by that? That means I need to rewrite this function to make it look like f of x either plus or minus some sort of alpha degrees. All right, and then that'll tell me how f is shifting left or right. Okay, because if you put x plus alpha, some alpha degrees into here, then what you're actually changing is a times tan of b times x plus alpha plus p plus q. So now your new phase shift is no longer just this plus p, because when you distribute out, you're going to get bx plus b alpha plus p. So here is a new phase shift. Okay. So let's see how we do this. So I'm going to write this as negative 2 tan. So now what I'm trying to do is to just get the b value 3 over 2 by itself and then rewrite this expression as x plus or minus some degrees. Okay, so I know it's plus 60, so I need plus here. So how do I get the 60 degrees, or how do I change the 60 degrees appropriately here so that when I multiply it out by 3 over 2, I get 60? Well, I do the reverse operation. I divide by 3 over 2. So that's the same as multiplying by 2/3, and that's going to be 40 degrees. Okay, so if I put 40 degrees here, you can see if you expand this product out now, that's going to give you 3 over 2x, which we've got here, and then 40 degrees times 3 over 2 is going to give you 60 degrees. So this is exactly the same expression. Okay, but this thing here is f of x plus 40 degrees. Okay, because if I plug in now x plus 40 degrees for f, that's going to give you negative 2 tan of 3 over 2. Now instead of x, you're writing it as x plus 40 degrees. Okay, and that's exactly what we have here. So what's actually happening is that the graph F is being horizontally shifted to the left by 40 degrees, not by 60 degrees. Okay, so very subtle one, but as soon as you have a b value that's not 1, that's affecting your x, then slapping a plus or minus p value here does not mean that that is the phase shift. It means you've got to rewrite it so that the period value gets taken out completely here. Then what's ever left over here tells you the phase shift. All right, so that is how we would do this type of question. I'll see you in the next one.